The reason that central atrium actually was in there is that we did some fairly early on some analysis of, okay, how do we get daylight into this space when it's covered by buildings? This is a stereographic projection of the overshadowing of the site. So it's basically you lying down on your back looking straight up at the sky with a fisheye lens with the amount of overshadowing. But essentially from that analysis it showed quite succinctly that the best place to get daylight into the building is right in the middle. That had the most access to daylight, thus the most logical place to put an atrium. These images then show some of the atrium images that were envisaged out of that. We went to a much squarer atrium as a result of having to integrate with the building structure that was holding the building up rather than the curved entry that you saw previously. The other key aspect of the building was we did a I'm going to mention it later on, but I'll mention now. We did a two-phase approach on this building. The first phase involved the exploratory strip out, essentially. So, as you saw before, that photo of, we didn't actually know what was in the building, in a sense, because it had been, overbuilt in certain areas. So the first phase actually stripped out a lot of the building to look at the heritage value that was left in the building of the cornice mouldings and of the ceiling details in the original building. That allows us then quite quickly to find out what the value of that was. A lot of the heritage conditions were still there. A lot of the original cornice mouldings were still there. So we sought to expose them, and that became important later on in terms of the type of mechanical system that we chose for the building. I'm going to flick through these ones there. Essentially what the building is now and the different floors, how they configured the basement and the top of the building with a breakout space, and a quick section indicating how the atrium was to work from an environmental point of view. Essentially the atrium was envisaged as also a communicator between the different floors. So it's an open-edged atrium that allows, let's say, people to visually communicate between floors, which is very important in current commercial properties or office properties, is the ability to put large teams of people together and have them communicate and bump into each other. And that is done through visual aspects through the atrium, but also the open edge allows you to actually communicate verbally through those edges. Secondly, it allowed us to draw air through the atrium back to return air path, and allowed us to naturally ventilate parts of the building. All right, so that gives you a kind of bit of a background of what the final design was. I'm now going to just focus on the environmentally sustainable points that we focused on for the building, other than just the building form. So our first step is usually to design the outside. When we design a building, like from a sustainable point of view, we try to design from the outside in, start with the building fabric, get that working well, and then start looking at systems within that particular building. So after, with a heritage building, we can't do that much other than put that atrium through. Now we start looking at the internal systems. This is an early hand sketch of the proposed system that we suggested implementing in the building. It's called a displacement chilled beam. It was mentioned previously for the wool shed. It's a very similar system. Essentially, you put a raised floor in the building. You pass air through that raised floor that comes out fairly close to your work environment. It's fresh air. And that is augmented at high level with what's called a chill beam. It's essentially like a radiator, but instead of it being a hot radiator, it's a cold radiator, quite simple. So that was an early concept sketch, and the real reason for that was to try and minimise the size of the raised floor and the amount of air we have to pass through the system. Can anyone hazard a guess why we would like to minimise the amount of air passing through the system from a mechanical point of view? Not necessarily reduces energy cost, but often helps. From a heritage point of view, when you're pumping air, you're talking about volumes that are that big. When you're pumping water, you're talking about volumes that are that big. Yeah? So typically for heritage, we try to pump more water than air when we can, because it means that we don't have to affect the fabric so much. We don't have to put such big kind of rises or holes or chunks through the building. Yeah? Thus, this is the preferred system at the type. However, because the floor-to-floor height was so large, we could actually implement a pure displacement system without any further chilled beams above. All we had to do is find one or two riser sizes, and there was one or two spaces that fit the bill that we couldn't actually use in the stairwells and the like. So as a result of that, we went for what's called a displacement system purely, which is where you just have a raised floor, you pass air into that, and that air cools you. Its key benefit from an energy efficiency point of view is that you're providing air at a fairly high temperature, about 18 degrees, and it means that for most of the year, actually, you can use outside air. You're not actually having to use chillers and the like to provide your conditioning. So it's quite an energy efficient system. It's also what we call a low pressure system. So the air coming in is very low pressure. As a result, you don't need to use fans so much. The third nice thing about this system is that the air comes in from below here, and then it kind of pools like you might see when you pour some water into a glass. It essentially stays at the bottom there, which is great because that's exactly where the people are in this space. Yeah? So it's conditioning people directly where they're sitting rather than having to mix it all up with a conventional air conditioning system. And finally, it augments well with natural ventilation because you can actually run it simultaneously. That's an image of the diffusers that you see. So air is delivered via a series of diffusers in the floor. You can move them around. So if you put some furniture nearby and the air is coming too close to you, causing a bit of draft, you just move it to a slightly different spot. The third thing that we really liked about this system is that we could implement a lighting design which is direct and indirect system in terms of a series of lily pads that allowed us to actually light those features, the heritage features of the cornice mouldings in the space. And I don't have a good image of it. It was remiss of me. I deleted the back of it because the presentation was running too long. All right, the 39 Hunter Street in the end achieved a 6-star Green Star rating in design. We're currently going through a process of trying to get the same rating for as-built, and I think we're doing a submission in another week or two for the first round of that. From an energy efficiency point of view, it's been modelled to achieve 5-star plus 40% in design, which we believe will give us around the 5-star plus 20% in operation. To put it in context, it was originally 2-star neighbours, so we've more than halved the energy use per square metre for this particular floor plate. We put a series of waste management strategies together, so all that strip out, the original strip out process that we did, we looked to a charity to come in and take what it required, and so sold off parts of it, and that went to the charity. Anything left went to an urban recycler, and the last reuser, and the last bit was recycled. We've done a process what's called shell and core, which is not often used in Australia. So we've only fitted out the floors that the tenants would look at as a display suite. Yeah. So the rest of the floors, there's actually nothing there. The advantage of that, often they get, on normal commercial buildings, they get fitted out for the tenant, and the tenant comes in and says, no, I don't like the carpet, throw that out. Don't like those light fittings, move those things around, and you actually have a lot of waste, so it avoids that particular issue. What are the other issues? We've put carbon dioxide monitoring in there to make sure we maintain the amount of fresh air coming into the space. We're reusing the water in toilet flushing. And with all these sensible approaches, we managed to get the building to a high 5-star Green Star design, just very simply by talking to the client about the benefits of each of those items. When we showed them then the analysis of the fact that we were only about 4 points shy of 6-star, all of a sudden the 6-star target, which we'd kind of been talking about, was much more achievable, and as a result we added in 1 or 2 additional items. So some of the innovations that were implemented here included the strip-out process, included the sprinkler tank at the top of the building. We insulated that, and we essentially pre-cool it at night, and we can reuse some of that cooling. Now, the real reason for using that approach is that we were very limited on how much electricity we could draw on this particular site. And Energy Australia said if we went over a certain amount, we'd need to put a new substation on the site, which you can imagine for a heritage building is not an easy thing to do. So essentially we used a combination of thermal storage and gas-fired chillers to draw down that peak energy demand, as well as focusing on the energy efficiency process in the first place. That allowed us to avoid having to put a substation on site for the additional electrical load by reducing it by over 40%. The interconnectivity of the atrium and the tenancy spaces, we use very efficient mechanical systems, a face bypass system, which is quite nice. It means that when we're not having to cool air, we can just deliver it direct to the space, and daily lighting control. So there are some of the innovations in the space that you see before you, and some of the other features of the gas-generated emergency power system and a glazed roof. The building is currently being fitted out by a tenant. We have a very happy client, and we hope that it will achieve very high energy efficiency ratings in operation. That is our key target. It's not the design of it, but the actual operation of it. So I guess I'd like to be able to leave you today with the idea that with heritage buildings, they can be made to be very sustainable. They can be done so within commercial parameters and speculative budgets with the right design, and that they actually are a great opportunity in getting, I think, value out that a lot of people don't actually see necessarily. So you do need a good kind of client and design team to get there. Thank you.
I could just ask our speakers to come up and join us for Q&A. So I guess we've covered an interesting range of topics from regulation and adaptation through to the sort of morass of variables that have to be considered in valuing heritage and valuing the economics, what works in the economics of redevelopment of these properties. And I guess the final presentation is the opportunities that can be exploited through creative design and engineering. So we've got about 10 or 15 minutes before we break for questions from the audience.